We are doing learning target number 8. Thank you. We did part 1 Friday, so we're going to do part 2 today. And this I can statement is I can solve compound inequalities. And part 1 was I can describe and graph them. So today we're going to solve them. All right. So here's what solving a compound inequality looks like. So if that plus 5 wasn't there, it would just be 6 is less than x, which is less than or equal to 11. I would graph it. I would describe all the numbers that fits that solution set, and I would be done. Except they're not just telling you what x is less than or equal to. They're saying x plus 5. And if you were to look at this as the way we did it when I first explained it to you by separating them, like if you just said, well, I'm going to cover this up, and I am given x plus 5 is less than or equal to 11. That's one of them. Or if I covered this one up, then I had x plus 5 is greater than 6. Because if 6 is less than this, then x plus 5 is greater than 6. And then you have two separate inequalities, which you then could solve separately. Subtract 5, we've done this. So one of your inequalities is equal to x is less than or equal to 6. And subtract 5 again. And the other one is x is greater than 1, right? So basically what we did is we took the fact that there's an x plus 5 here and an x plus 5 there, and we combined it, right? Just like we did in part 1, and we only wrote it once. But then the answers, so it's kind of like I separated them, I solved each of them, but now I just have two answers, and the back of the book does not give answers like this. We have to put it back into a combined. So this is kind of a big process here. It's a pain in the butt. So this, I got my 1, I got my 6, I got my x. Well, this is less than or equal to 6. And if the nose is pointing to the 1 here, keep it. Then I can do my graph. 1 and 6. And remember, your numbers always should go where they are in relation to each other on the number line, right? So this is open. This is closed. And I'm going to show you with a pencil because remember I wanted to show you what, like if this is all numbers greater than 1, but less than or equal to 6, I don't really want your graph to look like that. How they want it to look is that, right? Remember that? So they don't want to see them both. You may need to do both, and you may need to do that to kind of visualize what it's going to look like. Okay? And then if I were to ask you to give me a list, that means that the values for x could equal what? Give me all numbers that are greater than 1, but they also have to be less than or equal to 6. Dylan?
2, 3, 4, 5, 6.
Yep, 2, 3, 4, 5, and 6, and that's it, right? And if that wasn't darkened in, if that didn't include 6, then 6 wouldn't be in your list. Okay, well, kind of a pain in the butt. I'm going to show you a super shortcut way to do this. Instead of separating them, solving each of them, putting them back together. I'm going to have you just kind of look at this as a three-sided inequality. Remember how we always say do this to both sides? Well, in addition to being, there's 3 sides now. So can I just subtract 5 from the middle and cancel it there? But if I do it here, I have to do it here, and I have to do it here, right? And when that happens, I get 6 minus 5 is 1, less than x, less than or equal to 6. My answer is already how it's supposed to be. I didn't separate. I didn't have to put it back in combined and form. It's literally like three-sided equation or inequality, and just do the same thing to all three parts. To the 6, to the x plus 5, and to the 11. Not bad, huh? Okay, so let's take this one. Negative 7 is greater than y minus 8, which is greater than or equal to negative 12. So you could look at it as, I'll separate it, or you could look at it as, why do I need to do that? All I'm going to do to get y by itself, this is like a one step. If I add 8 to all three sides, I'm good. Y is by itself. Add 8, add 8, add 8. That cancels, and that gives me 1 here is greater than y, which is greater than or equal to negative 4. Okay. Now, we have to stop here for a minute and take a look at this, because that's not going to be the answer that's in the back of the book. The back of the book is going to have something a little different. And remember what I said about ands? How should the numbers be written in your answer? With the numbers and the relation that they are to each other on the number line. On the number line, is positive 1 to the left of negative 4? No. So I need to fix this. I still want the y in the middle, except this time I want the negative 4 over here and the 1 over there. And now I just have to kind of make sure I get those signs where they're supposed to go. So, I'm not kidding you, it sounds so silly, but think about that little nose. So how else can I rewrite this to have it match over here? This way, right? Okay with that? How can I write this to have it match over here? What sign would need to go right there? The point is towards the y. Okay? So it's not just to flip these, like this didn't come down here. You just take a look at that inequality and say, okay, now I need the 4 over here. This symbol needs to go that way. So your answers, this is okay. This is your best. This is how you want your answers to be. Okay? Yeah.
So we don't have to solve it?
You just did. You solved it. You told me that the value that would make this inequality work would be all of the numbers that are greater than negative 4, greater than or equal to, and less than 1. So x could equal, let's do this real quick, negative 4, 1. I'm not kidding you. If I ever ask you to give me the list, graphing it is your best bet first, because you really can see then, as long as you graph it right. So color this in. Don't color this in. Y is greater than or equal to negative 4, but less than 1. So x could equal what? It could equal negative 4, negative 3, negative 2, negative 1, and 0. And that's it. So, Esteban said, do we have to solve it? You just did. This is your answer. Yes.
So, if we put just the OK version, will we
I doubt, yes. I want you to take it to the full, that's a good question. I want you to take it to the full best answer. Yes. So, don't mark, yeah, I want you to have the best answer there. Okay, that was one step. Let's take a look at this. Negative 6 is less than negative 3n plus 9, which is less than 21. So now in order to get n by itself, I have to do two things, which is why they call it a two-step. First, I need to cancel out the 9, and then divide by, be careful, what am I going to be dividing by? A negative 3. Are you anticipating what is going to happen when you divide by that negative 3? Yes, you're going to flip them both, right? So let's see what this looks like. Subtract 9, subtract 9, subtract 9. 3 times. There's 3 sides. Negative 6 plus negative 9 is negative 15. Now, did I divide by a negative or multiply by a negative? No. Don't flip them until you actually do it. Negative 3n is less than negative 12, or positive 12. Okay? Now, what am I about to do? Divide, not both sides, but all 3 sides by a negative number. And totally up to you at this point. You may want to look at this and say, okay, before I forget, I'm not going to write any numbers down. I'm just going to switch those right away. Maybe you want to do that so that you know that you switch them. And the reason that these went to this is because of that right there, right? And then that gives you n in the middle and negative 15 divided by negative 3 and 12 divided by negative 3. Is my answer how it should be? To be the best answer it can be? No, because negative 4 is not to the right of 5. So I'm going to put a negative 4 here, the n here, and the 5 there. And then you just got to get those signs in the right direction. Okay? So for this one, n is less than 5. And for this one, n is greater than negative 4. Okay? So now that's written correctly. If I were to graph this, it would be negative 4, positive 5. I want all numbers less than 5, but greater than negative 4. So it's all those numbers in between, not including negative 4 or positive 5. So negative 3, negative 2, negative 1, all the way up to 4. Okay? Okay with that? So we did a one-step. We did a two-step. We saw switching it around. Let's do a multi-step. 7 is greater than, we haven't had fractions in a while. 6x plus 18. We got to keep you on your toes. I'm giving you an easy fraction, though. Or an easy one to distribute, at least. All right. So first I have to distribute this 2/3. And I don't want you guys freaking out and going, oh my gosh, it's a fraction. I don't know what to do. Yes, you do. You've been multiplying fractions since, what, 4th grade? So 2/3 times 6. Cross cancel, right? So 3 goes into 6 twice. And 2 times 2x is 4x. Now do 2/3 times 18. And cross cancel that. 3, 1, 6. So what's that? Plus 12. All right, I want to take a minute to kind of make sure you were with me at what we just did. Yes?
Where did the 2x go?
Which 2x?
So, yeah.
It got multiplied by this 2. Because you get multiplied by the numerators. So 2 times it turned into a 4. Okay, so once you distribute, now it's just a good old regular two-step equation that you guys know how to do. Subtract 12 from both sides. That leaves you with negative 5 is greater than 4x, which is greater than or equal to negative 21. And you know what? This is a perfect example. Sometimes your answers aren't nice, pretty, neat little whole numbers. Sometimes they don't go evenly. But I'm going to divide. Am I dividing by a positive or negative? Does anything get switched around? Nope. Negative 1 1/4 is greater than still x, which is greater than or equal to negative 5 1/4. And because they want you to keep working, is that in the order that it should be in? Negative 5 1/4 is to the left of negative 1 1/4 on a number line. X is in the middle. And I really, maybe if you need to, just kind of box it off like this. And look at each of them separately. So where's in the negative 1 1/4, x is actually less than it. But for this one, x is actually greater than it. Got it? Okay. Yes?
What if you use decimals?
That's fine too. Totally fine. Yep. You could even kept them. Yeah, you could have kept them in prepper if you wanted. Okay? All right. So those are the ands. So the ors are actually a lot simpler because the ors cannot be combined, right? So you are seriously just looking at your ors as two separate problems that are done totally separate from each other. So for example, to solve your or statement, you would say, let's say 16 minus, or not minus, or less than negative s minus 6 Or, you're going to have to see that word there, 2s plus 5 is greater than or equal to 11. They have nothing to do with each other. They don't share a common x plus 5. They're two totally separate. That's how ORs are treated. You've done this before, right? Here you're going to add 6 to both sides. So this is going to be 22 is less than negative s. Now let's just finish one instead of starting the other. So this is where it starts to get a little tricky, because not only is there a negative that I'm going to have to divide by, the s is on the right. So let's do one thing at a time. Divide by negative 1. Should I also switch the s over here while I'm doing it? No, because if you switch the s and the sign at the same time, it's like you didn't switch anything. Do you understand that? So do this first. This less than becomes greater than because I just divided by a negative. So this less than is greater than because of that. And now I want to have my s on the left. So if negative 22 is greater than s, that means s is less than negative 22. So remember what we talked about, how it looks like it didn't really switch? But it did, because this s switched. Okay, I'm not done yet. That was only part 1 of the problem. Subtract 5. 2s is less than or greater than or equal to 6. Dividing by a positive, not switching anything. And now what an OR does is it says, okay, change your frame of mind now. Remember, I'm not looking for overlap. I'm just asking you, give me a number that is either less than negative 22 or greater than or equal to 3. So let's kind of see what that would look like here. Negative 22 is over here. 3 is over here. Here's all the numbers greater than or equal to 3. Here's all the numbers less than 22. So basically, it just can't equal any of those numbers in between. Right? Or your answer is just what you just solved it to be. It could be any number greater than 3 or less than negative 22. Got it? Yes.
Isn't 3 on the other side of 22? Oh, yeah, negative.
Negative. Yeah. Brandon.
So you don't have to list any numbers.
No, because, technically if you were being asked to list, I would say, okay, s could either equal 3, 4, 5, ... Or it could also equal negative 23, negative 24, negative 25, ... But here's the thing. This is just an even longer way to write that, isn't it? So this really is enough. This tells me my solution. You could say that s either has to be, and that's really what you're doing by solving the inequalities, is you're telling me. When I have you write the list, that's kind of an extra little thing I have you do to really make sure you understand what that means. So this is kind of a Mrs. Z made up thing. You're not going to really be asked to list them. This is really enough for your answer. Okay? Sometimes I think the list helps with your graph. Okay? That's all there is to ands and ors, solving them. Okay?